Hi, my name is Trevor Santiago, and I'm going to talk about how we can simulate stock prices using Monte Carlo methods. First, we'll go over a little bit of background on Monte Carlo methods and some definitions from the finance world that we'll need. And then we'll go over the procedure for running a simulation, and then take a brief look at the code. So what is a Monte Carlo simulation? First, we need to know what a Markov chain is. And that is a random sequence of events where the next step depends only on the state of the previous step. A simple example is with weather. Say one day it is sunny, and given that it's sunny, the next day has a probability 90% of being sunny also. It doesn't depend on what the weather was like 2 or 3 days ago, it only depends on right now. And a Monte Carlo simulation is the process of determining properties of a phenomenon using random sampling and the law of large numbers. Basically, what we'll do is run a lot of Markov chains to be our simulation, and we can draw some inferences from that. Now, on the finance side, a daily volatility of a stock's return is the standard deviation of the percent change, and the compound annual growth rate is going to measure the annualized return over a set time frame, and it assumes that any profits that are made are being reinvested. So for the procedure, first we're going to gather some data. We can use a Quandl API or Yahoo Finance, any stock data source that you want to use. And then we're going to calculate the volatility and compound annual growth rate, which I have examples of there in Python. Next, we're going to compute the distribution. We are assuming a normal distribution with mean equal to the compound annual growth rate divided by 252. That 252 comes from the number of trading days in a year. And for that normal distribution, we are going to set the variance equal to the daily volatility that we just computed. Next, just to check that everything's going as we plan, we're going to just sample 1 year of random returns and run a single Markov chain. That's what we have done there on the right. That's just an example of one run through. Lastly, we're going to repeat that step 4 thousands of times, and that will act as our simulation of stock movement over a year. And then optionally, but I think it's a pretty good step to take for inference, is to compute the probability of profit and the mean ending price after 1 year of simulation. On the left there, we have a chart of 3,000 simulations of Apple, and on the right, we have some inferences drawn from that chart. So we have the probability of profit of 90%. That means that 90% of those 3,000 runs ended above that red line, which was the current price of the stock. And the average ending price was about $258.16. And just a disclaimer, this is a random simulation and should not be used as investment advice or guidance. Now we will take a brief look at the code. Let me run through this real quick. It's going to take a second because I have the recording software going. There we go. Okay, so first we are using the Pandas data reader to get the stock data. It's a very easy tool to use. You just give it a ticker name for the stock, what source you want to use, and then optionally you can give a start and end date, and there's a few other parameters also. So we're using January 1st of 2020 as our start and December 1st of 2020 as our end. And then we are just going to keep the adjusted close because that's what we are using for our simulations. And then there's a simple plot there of what the adjusted close looked like over the last 11 months. Next, we calculate the percent change for the daily returns. This is made pretty easy by Pandas. They have a function built in. And then the volatility and growth rate like we discussed. and the distribution and Markov chain. Here we're using a random generator from NumPy using that compound annual growth rate divided by 252 and the daily volatility. We are taking 252 samples from that normal distribution and adding 1 to it, because down here in our Markov chain, at each time step, we are going to calculate the random return times the last time step. And to show that this is random, I can run this a few times and just show that that plot is going to look different every time. Okay, and now we are going to run a Monte Carlo simulation. Here we're just doing 3,000 trials, and we are collecting the end prices here so that we can run some inferences on them afterward. And here we see we got just under 91% profit from this 3,000 trials and an average simulated close of $259.81. And that is how we run a Monte Carlo simulation on stocks in Python. I will have this code and the slides in the description for anyone that would like to take a look. And thank you for listening.